This segment deals specifically with spoke tension, and in this segment I will try to show you why it is that high spoke tension is so beneficial to a strong, stable, durable wheel. We'll start by looking at two wheels. One is a wagon wheel and one is a bicycle wheel. In the case of the wagon wheel is made up of thick spokes. Now, each of these spokes must be thick enough to not buckle under a large compressive downward load. In the case of a bicycle wheel, we have highly tensioned thin spokes. In that case, the spoke must be pre-tensioned enough to not buckle under a large compressive downward load. Now, the wheel does not hang from these spokes shown here at the top. As the wheel turns, those spokes move down as the wheel rolls along the ground, and at the bottom of the wheel, they go through what we call the load-bearing zone. And the wheel actually stands on the spokes in the load-bearing zone. In order for that to work, these spokes must remain perfectly straight. Let's look at an example. Let's say I'm building a wheel with a static drive side tension of 120 kilograms of force. Here's our wheel. There's a downward force on that wheel because of the weight of the bike and the rider, but this spoke that is sticking out to the side is not feeling any of that downward compressive force. So without any compression on the spoke, I have a tension of 120 kilograms of force. The wheel turns and 90 degrees later looks like this. I still have that downward force from the weight of the rider and the bike, and that causes that spoke to now be under compression. Its tension is going to decrease slightly, but the spoke remains straight and the wheel stands on it because the spoke is acting like a long, thin pillar. For a given combination of a model of rim and a model of hub, and for example, let's say we're talking about a Shimano 105 hub and a Mavic Open Pro rim, the strength and durability of the wheel will depend on three things: the number of spokes, the amount of tension on the spokes, and the consistency of the tension. Looking at first at the number of spokes, if everything else is the same, then a high spoke count wheel will be stronger than a low spoke count wheel, roughly in proportion to the number of spokes. The next factor is the amount of tension. High tension is your friend. It's a good idea to consult any published maximum tension recommendations that might be put out by manufacturers, but if you can, set the drive side tension at 120 kilograms of force or possibly even more. Let's look at consistency of tension. Here's a rear wheel. Because of the geometry of the rear wheel, the tension on the drive side will be higher and the tension on the non-drive side will be lower. Let's say, as an example, we have 120 kilograms of force on the drive side, and let's say we have 80 kilograms of force on the non-drive side. I want to have consistency on both sides. So on the drive side, I want to have 120 kilograms of force plus or minus 10%. I don't want any spoke to be outside of that window. And on the other side, 80 kilograms of force plus or minus 10%. There are a lot of problems that arise from low spoke tension. For one, I'll have an inefficient wheel that will give me poor power transfer. It also will be a wheel that will not stay true. And it's a wheel that will keep breaking spokes. Now, remember this: wheels break spokes because the spoke tension is too low, not because it's too high. One of the many books I have is The Art of Wheel Building, as you see there, written by Gerrit Schroner. He is a long-time wheel builder in the European circuit, and I'm going to quote something to you from his book. Many of my colleagues are of the opinion that high spoke tension itself is damaging. They reduce the tension and finish up with soft wheels. Well, I will put it to you in writing that those spokes are going to break. Let's see what happens to a spoke when it goes through its tension cycle as the wheel spins. So there's the wheel, there's the downward load on the wheel, and there is a spoke going off to the side at about a 90-degree angle. This is the highest tension that spoke will feel. Now here we turn the wheel, and a minute later the spoke is pointing straight down. Now it's in the load-bearing zone, and this is the lowest tension that the spoke will experience. Then the wheel turns, and 90 degrees later, it's once again at its highest tension. And as the wheel turns again, that cycle repeats and repeats. We could plot a graph that would look something like this, where we have a mean tension or an average tension is represented by that dashed red line, and the spoke tension fluctuates above and below that line on a regular basis. That's a little bit simplistic, but it's a pretty good representation. If the tension on my spokes is nice and high, then I'm going to have a very small amount of fluctuation above and below the mean, and that's a good thing. Conversely, if my spoke tension is low, I get a big swing up and down around the mean, and that is not good. So with a wheel with low spoke tension, I have large tension swings with each revolution. Any given spoke goes from low to high and back and forth with a large swing. And the spoke gets jerked back and forth and typically breaks right there at the elbow. Now, by comparison, a high tension wheel will see a very small tension swing with each revolution, just a little bit below the mean and a little bit above the mean, and that means that the spoke is stable and will have a long life. Lastly, here's a quote from Calvin Jones, who you see on your right. Calvin wrote the Big Blue Book of Bicycle Repair, and here's what he says about spoke tension. As the wheels rotate while you ride, the spokes that are on the bottom next to the ground will momentarily lose their tension level, then regain tension as they rotate past this low point. This change of tension in each revolution is called a stress cycle. Wheels with a relatively low overall spoke tension actually endure a greater swing in tension compared to wheels with greater overall tension. Stress cycles, the loosening and retightening of tension, fatigue the metal and lead to spoke breakage. Wheels with low overall spoke tension will loosen even more as the bike is ridden. This results in shortened spoke life, spoke failure, and a wheel that requires continuous truing.